Example 1.3. Check that the ratio Ke square upon GMEMP is dimensionless. Look up a table of physical constant and determine the value of this ratio. What does the ratio signify? So in this example, first of all we have to find out the given ratio is dimensionless or not. And then by substituting the values, we have to find out the final value of the given ratio. So we have to substitute the values of this physical constant, as we see that K is the electrostatic force constant, E is the charge on electron as well as charge on proton, the magnitude of charge, G is the gravitational force constant, M is the mass of electron, and MP is the mass of proton. So all these values that we have, and we can find out the final value of the given ratio by substituting their corresponding values. And then we have to find a conclusion that what this actual ratio signifies. So there are three steps we have to follow. In the first step, we will check the given ratio is dimensionless or not. So let's solve it. As we know, K is a constant, that is 1 upon 4 pi epsilon naught, and as epsilon naught is permittivity of free space, epsilon naught is the permittivity of free space, and its value, K value, is 9 into 10 raised to 9 Newton meter square per coulomb square. Then we have a charge on electron or a charge on proton, charge on electron or proton, or proton, which is 1.6 into 10 raised to minus 19 coulomb. Then gravitational constant capital G, 6.67 into 10 raised to minus 11 Newton meter square per kg square. Then Me is the mass of electron, which is 9.1 into 10 raised to minus 31 kg. Mp is the mass of proton, which is 1.66 into 10 raised to minus 27 kg. So let's substitute all this value in the given ratio, as we have Ke square upon G Me Mp. For K, the unit is Newton meter square per coulomb square. Square of charge on electron and proton is in coulomb square upon gravitational constant unit Newton meter square per kg square, and the product of masses of electron and proton, that is kg square. So in this way, these values are getting cancelled, and finally the dimensions of the given ratio is 0, and hence it is a unitless or dimensionless ratio. So in this way, we have proved that the given ratio is dimensionless. So our next task is to finding the numerical value of the given ratio, that is k e square upon gme into mp. So let's substitute the values of given ratio k e square upon gme mp. It is 9 into 10 raised to 9. E is 1.6 into 10 raised to minus 19 upon 6.67 into 10 raised to minus 11. ME is 9.1 into 10 raised to minus 31. MP is 1.66 or 67 into 10 raised to minus 27. So these are the values that we have, and we will solve the given problem using log table. So before that, let's simplify it like this: 6.67 into 9.1 into 1.67. So into 10 to the power of 9 minus 19 minus 19, as it is square, and this all powers will get positive because of the shifting to numerator. It is 10 raised to 11 plus 10 raised to 31 plus 10 raised to 27. Now the task is to apply log for this ratio. So log of the given ratio, 9 into 1.6 into 1.6, 6.67 into 9.1 into 1.67 is equal to log of 9 into 1.6 into 1.6 minus log of 6.67 into 9.1 into 1.67. Next, log of 9 plus log of 1.6 plus log of 1.6 minus log of 6.67 plus log of 9.1 plus log of 1.67 is equal to. Now you know that how to find the log of these values, and I am directly mentioning those values here, that is 0.9542 plus 0.2041 plus 0.2041 minus 0.8241 plus 0.9590 plus 0.2227. So by calculating these values, we will have 1.3624 minus 0. Minus 2.0058, which comes out to be minus of 0.6434. So now we have to find out the antilog of this value, and there is another method to find the antilog of negative number. So the next task is to find antilog of negative number. How to find this? So finally, the log of given ratio is minus 0.6434. Now, we will use the following method. And minus 1 plus 1.0000. And if I add these values, I will get minus 1 here, and 1 minus 0.6434 is 0.3566. Finally, I can write this number as 1 bar point 3566. So, the actually log of this bracket is 9 into 1.6 into 1.6 upon 6.67 into 9.1 into 1.67 can be written like this. Here I am simply adding and subtracting plus 1, and the entire value will again get added with the corresponding mantissa and the characteristics, and finally I come up with this number. And now it is easy for me to calculate the antilog of this mantissa. As we are interested in while finding the antilog, we are interested in mantissa only. So now we have 3566 value, and we will find the antilog of 1 bar point 3566, and the answer for it is 0.2273. 2273. We have to check in antilog section, that is 0.35 and 66. We will get this value, and because of 1 bar we will have a 0.2273 as an answer. This approximately comes out to be 0.23. Now, what we have is this entire value, and we simply apply log to this column or ratio. So finally, we have to write that k is square upon g MEMP, k is square upon g MEMP is equal to 0.23 into, now this 10 to the power, this is a big number, we have to add up and subtract it, and finally we will have a 40 is the answer. So power of 10 is plus 40. Now we can write this as a 2.3 into 10 raised to 39, as the ratio is dimensionless, so the given magnitude as a 0 unit. So this is what our answer for the step 2, that the numerical value for the given ratio is 2.23 into 10 raised to 39. So finally, we have to find a conclusion for this problem. In this problem, we have two particles. One is electron and another is proton, and we will consider that the distance between the proton and electron is fixed. It means by considering R value fixed, we are going to take ratio of electric force or electrostatic force to gravitational force. So if we do so, what we have is k q1 q2 upon r square upon g m1 m2 upon r square. Now observe carefully here. Q1 is charge on electron, let us say, which is E. Q2 is also charge on proton, which is also E. The magnitude is same here. M1 is mass of proton, let us say, and M2 is mass of electron. Then, by considering the R value fixed, we can cancel this and finally left with k square upon g mp me or memp, whatever, and this is actually the ratio of the two forces, the force due to electrostatic attraction or repulsion and a gravitational force. So we already derived the value, that is 2.3 into 10 raised to 39, and it is a unitless. So the conclusion is the electrostatic force between the proton and electron is 2.3 into 10 raised to 39 times the gravitational force between the proton and electron. It means the magnitude of electrostatic force is stronger than magnitude of gravitational force. So we will write here electric force is 2.3 into 10 raised to 39 times larger than gravitational force. As here we know that the electric force is between the proton and electron, the given force is attractive in nature, and the gravitational force is always attractive in nature, but the thing is its magnitude is these many times larger than gravitational force, and this is what the conclusion is.